thanks a lot for the invitation, and I hope you have a great breakfast. I don't know. So yeah, today I will be talking about language model agent. Maybe you heard about this a lot recently. Basically, it's how to use language model to build agent system. The title of the talk is Building AI Society with Agents. What is AI society here? I imagine it in the future. Many of the things in the society will be replaced by agent, or agent and human. They will collaborate and coexist together. So this is what I imagine in the future AI society. So it's very important to see try to understand how human and agent can collaborate, how agent they can collaborate with each other. Okay, good. Yeah, I'm now a postdoc at Oxford with Vector. So today agent is not a new concept. Agent is a very old concept from more than 30 years ago. One of these, I really like this book called Society of Mind. In this book, agent was discussed very deeply. So first of all, how do agents work? What are they made for? How do they communicate, and where is the first agent come from, and so on. I really recommend, if you want to learn agent, maybe you should start from this book. The main philosophy of this book is that agents, they are mindless process. Agents by themselves, they can only do simple things. But if you join those agents, those very simple agents together, become a society, then this leads to the true intelligence. So the core idea of this book is that the diversity is the secret that lead to intelligence. How human diversity come from how human intelligence come from those small agents and the diversity of the agent. Of course, in this book, it's a very old book. They are not deep learning at that time. Those agents are symbolic agents. So you define those agents by some if else. If you have here, maybe you can see the agent that can detect a table. If you have maybe 4 legs or something, then this is a table. This is a very symbolic agent. But in this book, Minsky, the author of this book, already discussed so many concepts nowadays we talk about in language model. Maybe you know the memory of language model. We use vector database. We have this short-term memory, long-term memory design. But in this book, Minsky already talked about that. Maybe you know chain store. In this book, it mentioned chain reasoning, basically the same thing of chain store, and how you can build communication among agents and also the work model. So yeah, that's why I want to start from this book, because it's kind of forgotten, but it's a very important book. Why this book is forgotten? Because related to the AI winter, maybe you know the 2 AI winters that firstly we have went through. So Minsky is the guy who created the first AI winter, because he wrote a book about perception. Perception cannot do at all. This is the one of the key events that lead to the first winter. So now most of us we do deep learning. So yeah, so basically this guy he's the father of AI, but mostly do symbolic AI. So it's 2 different community. Another agent, concept recently is maybe you are very familiar with, is agent in reinforcement learning. in reinforcement learning, agent basically is a learner, is a decision maker that you can interact with the environment. You perform action, and the environment gives you feedback and observation. And then based on the feedback and observation, you update your policy to maximize the reward from the environment. Right? So those agents, those IL agents, was like widely used in backgammon, Atari game, AlphaGo. Actually, yeah. When I started to do deep learning, this AlphaGo, I thought, oh, AGI is coming. I need to do deep learning. But yeah, but if you look back at that time, you'll find that like those IO agents have their limitation. They cannot generalize to other tasks. You can only train it in this like small world or small like environments, but it doesn't generalize to other tasks. You train it on the Go on this Atari game, but you cannot use it like for robotics or something. So because of the generalization, I guess yeah, those IO agent doesn't actually apply to the real world as we expected. There are many papers on this. I don't want to go through. And recently, there is new kind of agent, new kind of species of agent called language model agent. One of the most earliest work is called WebGPT. What does it mean? So basically, it's an agent. It's a ChatGPT, but it can use Google search or use like Bing. Maybe you now use a lot of ChatGPT. Maybe you know that. But this is one of the earliest one. They use this agent language model. They use this web browsing to improve the factuality of your language model prediction, right? So basically, you can do web search just like human. One of the most popular book about language model agents from this Lillian from OpenAI, this researcher. She wrote this book like language model agent basically composed by the memory, the tool usage, the planning, the action. Of course, there are still lots of things missing. For example, the communication, the learning parts of the agent, and the embodiment of the agent. Of course, this already mentioned by Minsky in the society mind. This is funny. So I propose a hypothesis of agent scaling law. So we know the scaling law of model. We have lots of parameters. We have many training data, and we train it for a very long time, right? So this leads to the scaling law of the foundation model. I propose a hypothesis here. So if you have agent, and you have lots of agents, like thousands of agents or more, and you let those agents to interact with many environments, and also the agent can build their memory through the interaction with the environment. I believe this will lead to the next level of intelligence by building this multi-agent system. Okay, that is the background I want to introduce. And today I will mainly talk about the recent work on multi-agent system with language model. So Camel is one of the earliest one. More than 1 year, we proposed this how to use language model to do role play and generate data and do task automation. Let's go into it. Okay. So Camel basically is is a framework that we propose that language model to do role playing, and by prompting them in a way we call inception prompting, so that they can automatically prompt each other. Basically, one as the instructor, just like you, and the other one as an assistant. So you can build autonomous agent by having these two agents, and their collaboration. Collaboration are done by instruction following, which is like quite stable way to collaborate. Just like how human society work. If you have like one as the planner, another one as the executor, that's like easy to collaborate. I don't know why this doesn't work very well. Maybe I shouldn't point to here. I don't know. So here is the overall framework. You have so. So basically, you want to build autonomous system with multi-agent, and of course, this autonomous system need to interact with human. So maybe you as a human user, you have an idea that you want to build, but maybe you are not very familiar with this domain and you don't know how to do it. For example, here my background is like computer science. But I want to maybe develop a trading bot for stock market. That sounds interesting. But how can I do it? I can choose two agents. Like one is the Python programmer agent. The other one is the stock trader agent. And then I have a task specifier agent that help me to brainstorming the task into a reasonable task. For example, here, if I want to do stock trading, I don't know how to do it, but I can have an agent to help me to figure out how can I do it. Here, you can do sentiment analysis. You can monitor the social media platform. Based on the sentiment analysis, you perform the trading strategy. This is the most fundamental way to do trading. If you are familiar with trading, I'm not. Here, and then you can, and then you assign this task to two agents. One is the AI user, the other one is the AI assistant. The AI user will act just like human user. It will just, based on the high-level task, the AI user will give instruction one by one to the AI assistant. For example, here, the instruction will be, the first instruction will be install the necessary Python library for sentiment analysis and stock trading. And this AI assistant will install those packages, and then the AI user provide another instruction, like maybe you should import it, and then the AI assistant import those library, and then they start to build the trading program together. How can we make this happen? So basically, all is about prompting. First of all, you need a task specifier prompt that can help you to make the task more specific. So it's like you need to, the task specifier need to know who are those agents that they are working with, like the assistant and the user and the task, and then it will help with the brainstorming. And the assistant and the user system from this is very important. So in order to make them collaborate, they need to know who they are collaborating with. So here the information are. So you need to instruct the model. Maybe you are a stock trader, and you are a Python programmer. I'm a stock trader, and we are collaborating on building this trading bot. Similarly, you need to instruct the other agent as well. You need to tell the other agent you are the stock trader. I'm the Python programmer. We are collaborating on this task. And we also need some kind of like communication protocol. How do they talk to each other? For example, here, like you should give the instruction and the input if you have like additional parameter. And of course, you need to put some constraint and when to stop the conversation. Because it's autonomous system, they don't know when to stop. It's like a for loop. So you need to set up like a terminal condition. For example, here, if they think the AI user, if the AI user think the task is done, then the AI user should say something like task done or something to indicate the user agent think the task is done. So this is like simulating how human user is, right? Of course, by doing this, we can generate many like instruction following conversation. How many people fine-tune like language model before? Yeah. So maybe you know that instruction following data is very useful for fine-tuning, right? If you usually you train a foundation model, but you want the foundation model to understand your instruction, then you need to use this instruction data to fine-tune the model. This is why this is actually the side product of the autonomous system. We can use them to simulate. We can use them to do task automation. At the same time, we will generate many data by just simulating this conversation. So you can imagine that you can use GPT-4 to do the simulation, and you distill data and you use it to train your llama model, right? Okay. So some experiment we use them to like do collaboration, of course, for good like coding, other tasks. Of course, you can also use them to do some malicious task as well. And at the end, I will talk about some challenge that we found during the collaboration. Here, so basically, we want to simulate this small society. We maybe like here we simulate like this 15 assistant role and 15 user roles, and they collaborating on 10 tasks. All those are generated by language model. For example, here you have this accountant, actor, administrator as the assistant. You have this user role as well. Those are all like you can prompt the language model to generate those roles. Of course, you can also ask them to collaborate on coding specifically. For example, like Java, Python, and you use those languages to solve a problem in different domains. Here, for example, you use Java to solve some problem in like accounting, maybe agriculture, and then you can simulate this scenario to generate many data. The first question I want to ask is like, is very two agent better than one? So here is the conclusion. So if you let two agents collaborate with each other based on our evaluation, it's better than one single GPT 3.5. We used like these two agents. We used GPT 3.5 as well. So you can see more than 70% of the time, two agents is better than one. And also, is the generated data useful? So we want to verify two things. One is this multi-agent system better? The second thing is the generated data useful? So we use the generated data to fine-tune open source model, which is a wake one. You use GPT to generate data, and then use that data to fine-tune a wake model like llama or something. So here you can see, by using our data, you can simulate specific domain data, and then you find that the emergence of the knowledge of the wake model For example, here, maybe the table is not very easy to understand. But here, like, let's say you generate data in math. Before you use this math data to, so the language model 1 and 2, they are like similar. After you use this math data to fine-tune the model, it becomes like 3 versus 16. So it's a huge improvement. But if after you put all the data to fine-tune the model, you find that your fine-tune model beats the original model on all the questions, like 120 alpha, 120. Yeah, and also, of course, this is a very interesting approach to generate data. One of the most famous model called MPT, they use our data. The company is called Mosaic ML, and those guys they got acquired for 1.3 billion. Their model use our data. And then, yeah, so can you do even more? So you have these two agents to talk with each other. Both of them are actor. They collaborate with each other. Can we introduce kind of like actor-critic architecture? Yes, for sure. You can just introduce one more agent to do the critic, and so that you can realize this like tree search approach. You have two agents. They can give you like many like options, and you have one critic to select the options from the proposal, and then it's just like a tree search. I won't go through the detail. Of course, you can also equip the agent with like tools usage or something. For example, here you can ask these two agents to use hanging face, this hanging face transformer, diffusion model to generate image. So so that it's like even more powerful. Of course, this autonomous system is very dangerous. You can use it to collaborating on some malicious tasks. Yeah, the idea is to take control of the world, and then you have this multi-agent system to help you figure out how to do it. So yeah, there are many potential malicious usage. So we really need to make sure your system is safe. Yeah, many challenges during this work at the beginning. So one of the most difficult challenges that we met is the role flipping. Because you ask one to act as an instructor, the other one as executor, but sometimes let's say this assistant agent give an instruction to the user agent, and then the user agent suddenly say, "I'm sorry, but as a language model, I cannot do blah blah blah," and then this whole system break. I cannot. It just cannot like fulfill the role anymore. The second challenge we met is sometimes the assistant just repeat the instruction. I don't know why, but yeah, this happens. And sometimes the assistant agent just reply this like what we call it like flake reply. You can see this example. The user agent asks the assistant to write a script to generate some combination of all the, I don't know, and the assistant's the reply for the assistant is, I will write this script, but it didn't do anything. Just reply like this, just like how your boss tell you to do something. I will do it, but it never do it. So this is a huge problem. Also, people find that at some point GPT-4 also have this lazy problem. So yeah, it's very important to fix this problem when you do the role play. The last one is the infinity conversation. That's we pay a huge cost on finding this problem, because at the beginning when we built this agent system, we didn't realize that we need to let them stop. So they just talk with each other. After here is very interesting. After they finish the task, and the user agent said, "Oh, thank you," and the assistant said, "Yeah, welcome." And then the user agent said, "Thank you," and the assistant said, "Yeah, welcome. Goodbye." Yeah. If you use the API, you know that each of the message you need to send the whole history message to the API call. So this example costs us like 1,000 USD. Yeah. So yeah, you really need to define a good termination condition. Okay, that is our work. After that, there are many follow-up work, like concurrent work. One of the most famous one is this one from generative agent from Stanford. They have this 25 agent living in a small village, and they use it to simulate like social behavior. I just skip the detail. Of course, you can also use language model agent to simulate negotiation. You can use language model to simulate this like behavior against it. You can. People also find that you use multi-agent to debate can help with the factuality of your answer, reduce hallucination. In industry, people use those language model agents to generate animation, to generate episode, building this multi-agent system. I just skip this. And also, you can use it to build even larger multi-agent system. This is called one of the follow-up work that use our work to build, to use that to develop software. Basically, you have this like different agent, can be CEO, CTO, CPO, programmer, designer. So you have the whole company. Okay. Of course, you can also use those language models for robotics. Robot collaboration is a huge problem. As part of some of the tasks can be done by using language model. For example, these two robots arms, they can discuss on which one to pick. Like maybe the first one say, maybe I pick the banana, you pick the apple, something. Just by natural language. Poetry is very difficult. You need to do optimization, reinforcement learning. Another very popular agent is this Voyager agent. All the prior work I mentioned, they don't have environments, but this one is very cool. They have they put language model agent into Minecraft and let the language model to play Minecraft and learn skills in Minecraft. Yeah, maybe you remember I mentioned environments is one of the skill involved for agent. So that's why I mentioned this work. Okay, I guess almost. Yeah, so. Jingdong today tell me you need to mention something about multimodality. So this is why I put these slides here. So this is one work that I'm working on. Recently, okay, it's one work I'm working on recently. There's a multimodal agent. You put it into your desktop and your mobile. So there are multi-environments and multimodality and multi-agent. So you can see here. It's very small, but yeah, I just go through it. So basically, the agent can open Slack and read the Slack message, and then the agent open the phone and send a message on the phone. So it's a cross-environment multimodal agent. Yeah, I will just give it. This is something we are currently working on. Will be released soon, maybe this month. It's an open source project. This is the architecture. So we have these multi environments hosted by some virtual machine. We have multi-agent. They communicate with those environments perform tasks. Of course, they can also communicate with each other. The workshop today is about like trustworthy as well. So I also mentioned a work that we done recently. We use agent to simulate human trust behavior. So basically, ask them to play some trust game and see like how does this agent align with human. Yeah, thank you. At the end, I would like to thank every contributor from the Camo AI talk. We are an open source organization. We do open source projects, open source science. Yeah, thanks a lot for the contributor, and thanks a lot for your